Hello there, amazing people. We have a list of questions on the screen right now that we've been asked to do justice to. The question starts off by saying write balanced symbol equations, including state symbols, to describe the reactions below. Number one, lithium hydroxide solution in excess and dilute sulfuric acid. So this is a reaction between an acid dilute sulfuric acid and a base lithium hydroxide. So this is called a neutralization reaction. A neutralization reaction is a reaction that takes place between an acid and a base. Now the products of such kinds of reactions are two: is salt and water is what is formed. So let's go ahead and do justice to the first question. We have lithium hydroxide. Lithium hydroxide has the formula LiOH. Li stands for lithium and OH stands for hydroxide. This is in the aqueous state of matter because it was stated that it is in a solution. We have lithium hydroxide combining with sulfuric acid H2SO4. This is also in the aqueous state of matter. So what happens in this reaction is this metal lithium over here comes to hydrogen to displace it. Now in the reactivity series, lithium is higher than hydrogen, so hydrogen will have to leave and combine with this hydroxide to form water. So what we have is lithium sulfate. Lithium sulfate has the formula Li2SO4. This is also in the aqueous state of matter, and then plus water H2O, which is liquid. Now we've been asked to balance this chemical equation, so let's balance it. We start with lithium. Over here on the left we have one atom of lithium, over here on the right we have two. So to balance lithium we would have to add a coefficient of 2 over here. Now for hydrogen or for oxygen, we have one atom of oxygen over here and four atoms of oxygen over here. That makes 5 on the left hand side. For the right hand side, we have four atoms of oxygen over here and one atom over here. That also makes 5. Oxygen is also balanced. How about for hydrogen? Over here we have 1 multiplied by this coefficient of 2. That makes 2 atoms of oxygen, of hydrogen, I beg your pardon. And then over here we have 2 atoms of hydrogen as well. That makes 4. And then over here on the right hand side we have just 2 atoms of hydrogen. So to balance hydrogen, we'll simply add a coefficient of 2 over here. That makes hydrogen to be balanced. Now let's check out the whole equation and see if it's balanced. Lithium is balanced on both sides. Oxygen, we have 2 atoms of oxygen over here plus 4 over here. That makes 6. On the right hand side we have 4 atoms of oxygen over here plus 2 atoms of oxygen over here. That makes 6 as well, so oxygen is also balanced. And then for hydrogen we have 2 atoms of hydrogen over here plus another 2 over here. That makes 4. And then on the right hand side we also have 4. So this equation is fully balanced. That is for the first equation. Alright, so the next question says iron 3 oxide, an insoluble base, and dilute nitric acid. So let's do justice to this. The first thing we have is iron 3 oxide. Iron 3 oxide has the formula Fe2O3. Okay, and it's an insoluble base, so it's going to be in the solid state of matter, reacting with nitric acid, dilute nitric acid. It has the formula HNO3. This is in the aqueous state of matter. So this is combining to form a salt and water. So we have water H2O. What kind of salt is going to be formed? We have this metal over here coming to displace hydrogen. So when that happens, hydrogen would have to leave and combine with this oxygen to form water, which is what we have over here. Now, when this guy comes to react with NO3, we have the compound formed to be this is the compound that is formed Fe and then in brackets NO3 outside the bracket 3. This is going to be in the aqueous state of matter. This is in the liquid state of matter. So now let's balance this chemical equation. First, we have iron. On the left side, we have two atoms, and on the right, we have just one. So to balance iron, we add a coefficient of 2 over here. That way, iron is balanced. The next element, or the next ion that we want to balance, is the nitric ion, NO3. Okay, so on the left hand side we have NO3, just one unit of NO3 over here. On the right hand side you can see NO3 appears 3 times because of this 3 outside the bracket. So to balance it, we'll put a coefficient of 3 in front of this compound. That way NO3 is now balanced. Now let's check out hydrogen to see if hydrogen is balanced. So we have hydrogen. On the left hand side we have 3 atoms of hydrogen, and on the right hand side we have just 2 atoms of hydrogen. So how do we balance it? We can balance hydrogen. By making the number of hydrogen atoms on both sides to be equal. We have 3 here, we have 2 here. The lowest common multiple of 3 and 2 is 6. So if we put 3 here, we'll have to change this 3 over here to become 6. So that way hydrogen is now balanced, 6 on the left and 6 on the right. Now let's check out for other elements to see if they are balanced. Now we have changed the number of NO3 over here. Remember there are 3 appearances of this ion, okay, and then there is a coefficient of 2 over here. So that means 2 affects this 3. That means this ion appears 6 times. I trust you're following. Okay, so therefore this NO3 over here on the left and NO3 over here on the right are balanced. Let's check out for hydrogen. Hydrogen is also balanced. On the left 6 and on the right 6 as well. So now let's check out for oxygen to see if oxygen is balanced. How many atoms of oxygen do we have? On the left we have 3 over here, and then over here we have another 3. 3 times this 6 gives us 18. 18 plus 3, that gives us 21 on the left. How about on the right? How many do we have? Over here we have 3, and then over here we have 3 times another 3, that makes 9, times 2 here, that makes 18. 18 plus 3 makes 21. So this equation is fully balanced. Let me write it one more time. Fe2O3 plus 6HNO3 giving 3H2O plus 2Fe. This is the full balanced equation. That is for the second one. And then the third one, zinc metal and dilute hydrochloric acid. Zinc has the formula Zn. Of course, this is going to be in the solid state of matter because it's a metal. And dilute hydrochloric acid. Hydrochloric acid is HCl. This is in the aqueous state of matter. So what happens is zinc comes over here to displace hydrogen. Hydrogen has to go, and then it's standing alone now. So this chemical reaction is actually going to produce hydrogen gas, and then zinc combines with chlorine to form zinc chloride, ZnCl2. This is going to be in the aqueous state of matter. Now let's balance this chemical equation. On the left hand side, zinc is just one atom. On the right, zinc is also one atom. So zinc is cool. For hydrogen, on the left hand side, we have 1 atom here and 2 atoms over here. So let's balance hydrogen by adding a coefficient of 2. And then for chlorine, we now have 2 atoms because of this coefficient of 2. And on the right hand side we also have 2 atoms. So this equation is fully balanced. We have Zn plus 2HCl yielding H2 plus ZnCl2. That is the full balanced equation. I trust you got massive value for this. If you did, please do well to like, share, and subscribe for more amazing content coming your way.